All right, cylinders it is. This is super easy concept, especially after we've done prisms. A cylinder is basically designed just like a prism. A prism has two congruent opposite parallel bases. Those bases are polygons. The only real difference is a cylinder has a circle as its base, right? And so that stacking principle still works, that we'd have that one circle and then we would stack it all over the entire height to get to that entire cylinder, right? And all of its inside volume. So that fills that whole inner region as you stack circle upon circle upon circle. It fills the entire volume of that. So I actually like this. I don't think many use BH because in this case it's not any base. It is exactly a circle. But I do like this idea that it's the same concept, stacking concept, as a prism, except it will always, in the case of the cylinder volume, will be that in our case, at least at geometry level, will always be a circle. No real trick in this first one. We have our cylinder, our circle there, and so it's just going to be volume equals BH. Again, that will always be a circle in the case of a cylinder in geometry's level, so it's pi r squared, that's your circle, and then your height is 5. Again, this is the this portion of it, and then we just multiply that out and we get 80 pi, and you can again turn that into a decimal if you would like, but I'm just going to leave it as an exact answer. Over here, we see the common trick played multiple times. We're missing the height. It's going to be 12 because this is a Pythagorean triple, isn't it? 5, 12, and 13. So I did a little Pythagorean theorem there to obtain the 12, and now it is just simply volume equals 1 base times the height. That base will always be a circle in this case, pi r squared. That's the circle times h, and that comes out to be 75 pi centimeters cubed. And again, I'm just going to leave that alone. No need to turn it to a decimal. The last two are starting to get a little bit more interesting, at least for me, I think. This is kind of like your toilet paper roll. Do you see that? How there's a hole in the middle. So if you think about a toilet paper roll, that'll make sense, that there's a cylinder missing down the middle. So when you calculate something like this, the big cylinder will be pi, r will be 8, pi r squared h. This is the calculation using, again, if this is 4, so would this. That's where I got the 8 from. And this would calculate the outer portion, or the entire cylinder. Now, inside of that, we have this kind of hole area, and it will be a smaller cylinder, won't it? It would be pi r squared h as well. And if I calculate this is 768 pi. This is 192 pi. I'm subtracting because it's a hole that goes, again, throughout that entire toilet paper roll. And when I find that, I get 576 pi centimeters cubed. Again, no need for me to turn that to a decimal. Now, it's quite fun because the next one kind of has some of that and a little bit more. This is a composite shape. You can see that there is a hole that goes straight through it. And so let's do each piece at a time. Let's do the big base here first. Pi, let's see, 14 is the diameter, so r would be 7 pi r squared, height's 11. I'm going to add that to my next guy, new color. Let's put him in here. He would be pi. His diameter is 10, so 5 would be his radius, and his height happens to be 5. And then we are going to subtract now this hole that goes all the way through this cylindrical hole, which is a cylinder. Pi its radius is 1 squared, and its height would be 16 from the looks of it. So let's figure out what each of these are. This is 539 pi. This is 125 pi. This is negative 16 pi. And when you put those together, you get your final answer of 648 pi centimeters cubed. Quite a bit of fun. And basically, we just did that in 3 parts or 3 pieces. Enjoy the cylinders.